Hello, I'm Trenton Clark with the Virginia Asphalt Association. And in this last presentation, we want to summarize everything that we've covered in this Asphalt Plant Level 1 curriculum. These are the things you need to know, not only to do the job, but as you go in and take that credentialing test. A few areas we want to review: plant safety, the loader operations, some of the plant operations, what are some of those common mix issues, and then lastly, some of the mix sampling that you need to know to perform your job as a Level 1 technician. So as we think about it, when we're at plant safety, we want to avoid confined spaces. As Michelle talked about in her presentation, those are areas that are big danger zones that we don't want to get anybody in where they can become trapped and either hurt or even killed. Want to make sure that you're wearing that proper safety material. Make sure you have your harnesses on where you need them, your hard hats, your steel-toed boots. These are all things that help keep you safe. We want to make sure you're visible. So make sure that the clothing that you have the reflective gear on, because those loader operators that are up in big pieces of equipment, we want to make sure they see you. And the same as dump trucks are going around the plant and other vehicles, we want to make sure that you are visible. And for goodness sakes, be careful around that hot asphalt, whether it's the mix or the binder itself. As we saw in those videos, what being covered in hot asphalt binder can do to the skin. And we talked about some of those corrective or some of those actions that can be taken in case you do get hot asphalt liquid on your skin. So please be safe. We spent a while and we talked about loader operations. Why is it so important? Because we don't want to segregate these mixes. From the very beginning, starting off at the source, whether it's at a quarry, gravel pit, whatever it may be, all the way through to that asphalt plant, we want to make sure that loader operator is not performing in such a way that is separating the large and the small aggregate. Because think about it, if we've got it segregated in the stockpile and that loader operator then takes that material and puts it in one of the cold feed bins, we've already got a segregated mix. And we're not putting that fine and coarse aggregate back together in the right proportions to make the material that was designed. Make sure that loader operator avoids digging into the ground. That's why we like those hard surfaces. A paved surface is the best surface for putting these materials. But we also want to make sure that loader bucket's not running right against the ground. We're trying to keep it at least 6 inches above and scoop it into the pile. Because we want to make sure we're not picking up any deleterious materials. Again, we don't want to have stockpiles that have grass growing around them. We don't want any little saplings or trees. But we also want to make sure it's clean, it's solid, and it's well draining. Finally, that loader operator needs to be making sure those stockpiles are separated. So when you're at the asphalt plant, is there either physical separation from one stockpile to the next, or are they physically separated by barriers or walls that may separate our 8s from our 78s or from our 68s? Whatever those aggregates that we're using, we want to make sure that they don't cross-contaminate, because we've put so much material together where we get an area where they blend, because then it's very hard to put together that mix that the designer designed. Let's move over to the plant operations. Make sure that we've got separation at those bins. So when that loader operator is dropping the material either into a cold feed or to a wrap bin, that again there's a barrier, there's a wall, so we don't have the loader dumping material and some of that spilling over into another bin. Very important. Make sure those belt scales are calibrated. Because remember, we're weighing the material as it's going into the plant itself. And by knowing the weight of the material, the plant can adjust for the AC content. But as we talked about all the way back in plant operations in Chapter 3, we need to make sure that we know the moisture contents and can account for that, because that moisture in the rock, that moisture in the wrap, is some of the things that adds weight. We need to account for that to make sure that the right amount of binder is added. Make sure the mix bin or the bin openings are correct. The gates on the bottom So if we're making a BM25, that's going to be completely different than an IM19, which is completely different from an SMA or SM95. So make sure those openings and make sure the materials are correct. You're checking the drum, you're checking the baghouse temperatures because we don't want them catching fire. But again, temperatures can build up if we're not paying attention to it and running the plant properly and having those baghouses run properly. Checking those baghouses, making sure the bags aren't full, making sure that we are getting the good separation, that we're getting the good material coming out, especially if we're feeding material from that baghouse back into the mix itself, making sure that we have a good check on that we get the same amount of material that we thought was in the design is being fed back. Because if you remember, a lot of those lighter materials are being pulled off from the vacuum. They're going into the baghouse, and to get them back into that final mix design, we're having to feed it back. Check the temperature of that mix at the chute. It's coming right out of the drum. You can take a temperature gun right over, measure it to make sure that we're within spec. Just remember, all the mixes have a top end of 350 degrees, but some of the binders that are polymer modified may have a top temperature that's less than 350. So again, ensure that you're not having that mix overheated during the production process, and the best way to check it is right there at the drag chute as it gets ready to go up the hot elevator into the silos. One other place that we can create segregation is right there at the dropping from the silo into the back of the truck. So making sure that you're getting the proper number of drops, especially when you have a lot of large rock, large aggregate in the mix. If you're not doing a proper 3 drops, you can pretty much guarantee you're going to segregate the mix. So follow the best operations to make sure that we're not segregating when we're going from the silo into the backs of trucks. What are some of the common mix issues? Well, segregation in the truck. That's one thing that we can see when you look in the back, because that truck's going to dump or take a load from the silo. It'll pull up to that sampling stand. You can look in the back to see if it's segregated or not. Did we not dump it properly? You're also looking for uncoated aggregate particles. You're seeing, is all the material that's visible coated well, or do you see a lot of aggregate that doesn't have coating on it? You need to back up. You've got a problem going through your plant. You're not getting enough coating time. Maybe that something went wrong with the asphalt pump and you're not getting the liquid. Use that immediately to say, whoa, we have a problem, and look for that type of thing. One of the things that has happened more than once, unfortunately, when you're producing a lot of material, going to a lot of different projects, you may have called for a surface mix, but you can clearly see that's not a surface mix in the back of the truck. Look for visibly larger aggregate. If it's a 9.5, you're thinking 3/8 of an inch is about the biggest rock you should see. So if you see 1-inch rock, a couple of things could have happened. One, is it really a 9.5? Two, when that loader operator was getting the material to dump into the bins, did something happen? Did he get into the wrong stockpile of aggregate? It's happened before. Could there have been some cross-contamination? So those are things that you can see visibly in the back of the truck. As that plant level 1 technician, you're the first set of eyes on that final mix. So when you look over to grab a sample or just take the temperature, you'll know. And then just measuring the temperature. Is it too hot or is it too cold? We talked about checking the temperature at the drag chute. You also check it in the back of the truck. You're checking that first load, that 5th load, at least once an hour. So are we above the temperature range, or is the mix too cold? If you're not using a warm mix technology, we don't have a temperature at the plant. We have a temperature in the field of 200 degrees. But you already know if you're not producing it at the right temperature with those technologies, it could lead to issues of placement out in the field itself. Some of the mix sampling guidelines that we covered in this class. One, the sampling is done by the contractor's Plant 1 technician. So you have to be Plant 1 certified to pull the sample out of the back of the truck, whether it's the AC content gradation sample or one for volumetrics. So you're either pulling a sample for yourself, or if the VDOT representative is there, you're grabbing their sample and you're grabbing the sample for them. Remember, when we're looking at AC content gradation, we're splitting it down on the table. Volumetrics, we're filling their boxes or their containers to take back to their lab to do their testing. Absent recovery, we include that. That's always at the discretion of the engineer. So not every sample do we ever do absent recovery, but if there's some concerns or we're just wondering what type of final binder grade we're getting, we can pull a sample there and do special testing back in the lab. And just remember, we're always doing our sampling through a stratified random approach. Our lot is 4,000 tons, so we have 8 sublots, so that's how we stratify them into 8 sublots. Each sublot has 500 tons in it. And within that 500 tons, then we're randomly sampling. So we can test the first 10 tons, or maybe it's the last 10 tons of that 500 ton sublot, or anywhere in between. One of the things that we always look for is there a pattern? Because if there's a pattern, then we're not following a random approach. So if you think about it, anywhere from ton 1 to ton 500 can be tested, and over a whole period of a season, you should see a pretty even distribution from the beginning of that 500 ton sublot to the very end. So again, make sure you're following that random stratified approach, and that's usually an approach that's been approved by VDOT. Either they're providing you a list of testing tons, or you provide them a list and they select. Just make sure the department has approved your sampling procedure. A couple other things and then we'll wrap up. Minimum sample size for AC content gradation is 10 pounds. If we're doing an absent recovery, we need that same amount of material. Again, that's very seldom tested, but it can be done. If we're doing volumetric, we need more because we're making pills, so we're up to 25 pounds. So when you're pulling material out of the truck, either from one location, as we typically do with AC content gradation, or at least 2 locations with volumetric, you're getting between 10 and 25 pounds. Again, we're doing AC content gradation every 500 tons. We're doing a volumetric testing every 1,000 tons. Just keep in mind, it could still be a slow production day, but once we're above 300 tons, but we may only make 600 tons of that mix this given day, somewhere in that 600 tons you need to do a volumetric. So once you exceed 300, we need 1 volumetric sample, irregardless of how many tons you're going to produce that day. The IA samples and the AC content, again, while the contractor is pulling samples, they're getting the material for them. They got to make sure the same amount of material is now available. So basically you're doubling the amount of material because you're going to break it down and you're going to keep different quadrants to do your AC content gradation. The department needs that complementary sample to do their same test because we're breaking it in half to see, are my results and their results equivalent? Do they match within reason? For VST, same thing with the volumetrics. We're checking the production testing. They still need, again, 25 pounds of material, so you may be filling some boxes for them to take back. They're completing that TL10, but it's all part of that VST process to make sure that when we're testing and we're getting volumetric properties and we're showing an air void content or a VTM of 3%, that the department, when they do their testing, are we comparing well? That way we can see, do we have roughly the same material through the whole process to make sure that it is passing. And if we have issues, then there's other processes in place that will be covered in the Plant 2 and the mixed design class regarding adjusting production or even going to limited production when we continue to have results that don't compare. Mixed temperatures, I mentioned it just a minute ago. We're doing the first and the 5th load of each mix type, then once per hour. So if you're doing an 8-hour shift of 12.5D, that 1st and 5th load that comes past that sampling rack, we're testing the temperature because by the 5th, we're seeing how well the plant settled out. Every hour, we're just making sure we're within the range. Again, keep in mind, max temperature is 350, but if we're using specialty binders, those binders may have a different top temperature, and they should be supplied by your liquid supplier. Keep in mind with our mixes, non-warm mix versus warm mix, you need to know if the technology is being used. So if we're using a non-warm mix, an S binder, which is going to be classified as an A binder on your contracts. So a 9.5A, we got less than 25% wrap. We have one temperature. A D mix, or the H, which we use very little H, but there are some spots around the state where we use that H binder where the wrap's not as plentiful, so we're not putting as much in it, so we have a different temperature, versus the E. And that's that very heavy loads. We're using those on the interstates. We're using those in SMAs primarily. So we're just checking the temperatures to make sure that mix going out, but also we're checking the minimum, because if you're already below 250 and you're using an A mix and it's not warm mix, you know the mix is too cold. So just check those temperatures in the back of the truck just to ensure that plant temperatures are up. With warm mix, really the big thing we're looking at, so if we're using an additive or a foaming process or some other way that's making it a warm mix, really the minimum temperature is 200 degrees, and it's really governed by what's going on in the field. But you can pretty much guarantee if a truck comes through with warm mix and it's already at 200 degrees, by the time it reaches that paver, it's going to be out of spec. So you can flag that, but most of the things that we're trying to catch are mixes going out too hot, typically in the beginning of the season, typically in the end of the season. Usually in the middle of the July, August, it's not that big of a concern, but by spec, you still have to check them. So let's wrap up. Be safe. Make sure you go home the same way you came to work. Loader operators can make or break your mix, and that goes from the quarry all the way to as they dump into the cold feeds. Make sure that they're able to do their job, and make sure as a plant technician, you're monitoring their job through what you're seeing in the mix. If you're seeing segregation, work your way back. Does it start with the loader operator, or is it something in the plant? But continue to make sure that plant or loader operators following good standard operating procedures. Plant operators, if you're in this class, you've got to watch everything. You've got different vehicles coming onto the project, you're watching, or to your plant, you're watching the plant operations, you're having to monitor what's going on tonnage-wise, so make sure that the samples get pulled at the right time. You got a very tough job, but it's important that you know all the different bits and pieces, so how what you do impacts that final mix. I've said it over and over, as the plant technician getting up to pull samples, you can spot problems before anybody else does. If you see an issue in the back of the truck, don't wait for it to get out to the project, and then the project starts calling back asking what's going on. If it doesn't look like the right mix, if you see segregation, if it looks too wet, if it looks too dry, spot it then before it goes out to the project, because you can be the initial set of eyes before we have any test results. Pulling samples and how you go about quartering them is critical. You can take a mix that passes spec, but by the way you pull the sample and the way you quarter it, you can take it out of spec. And a great example is, remember back with loader operations at the very beginning in chapter 3, John Hellyer showed that video. He took a material that was very uniform, and just by the handling of it, he segregated it. And you got two different set of test results, even though the mix or that material was fine to start with. All right, same with sampling and quartering. If you go about it the wrong way, you can take a material that's completely within spec, have it fall out of spec, open yourself up to a pay penalty for no other reason than you didn't do the process correctly. So it's critical that you follow the processes as laid out in the different VTMs and the different AASHTO procedures to make sure that we can take your process and how you go about it out of the equation. So if we do have a mix issue, we say it's not from sampling, it's not from quartering, it's from another area. So again, critical role, and that's what you as a plant level 1 technician is being certified on. And always be checking your aggregate. New loads come in, check your aggregate. Good quality control is check gradations when they come in, check your wrap gradations constantly, continue to monitor your mixed moistures, continue to monitor the individual products going in. So your different aggregates, your different wrap that's going in, make sure you know the moisture so that the plant can be adjusted accordingly to ensure you get the right AC content. So with that, if you have any further questions, feel free to reach out. I'd like to wish you good luck on this level 1 credentialing exam. And when you're successful with that exam, remember to sign up for your proficiency so you can get your full certification. Thanks a lot and have a great day.